Okay, let's look at chapter 2 together. In chapter 2, we are talking about local networks. Here is definitely talking about local telephone networks. We know that the more than half our investment for a telephone company is for the local loops, and the local network would include subscriber plant, local exchange, etc. We need to understand the elements for the local network. And also, when we're talking about quality of service and economy, we have to balance certain kind of different factors listed here, such as the percentage of business phones calling habits, because you can imagine that in an area there are a lot of business there, then the call density will be pretty high. Regarding the subscriber loop design, we need to balance many different factors. We also need to meet certain requirements such as louder rating, etc. And we need to understand how we calculate the loudest rating. Here is the formula for that. When we design the subscribe loop, we need to know how long the link can stretch. It's based upon what kind of uh, wires or the cables you use. The larger caliber, the longer distance you can carry. We need to know how to calculate the distance for us to stretch a link based on the wire with different caliber we're using here. Here we need to be careful is that we assume that there are certain amount of resistance is value is assigned for the instrument. So when we calculate the link distance, we have to subtract these. I mean, take out the ohm value for the instrument. The remaining value, ohm value, would be used to calculate the link length. And we also need to aware that the attenuation is based upon different factors. One of factors will be frequency, another will be resistance, inductance, etc. The maximum attenuation is 9 dB at 1000 hertz. And okay, we need to use table 2.4 to check the resistance for wires with different caliber. Okay. And in order to stretch the transmission distance, we can do several things. Like here, we use larger diameter wires, use amplifier, loading coils, etc. One thing you have to be careful is that when we try to use the existing link to carry DSL signal, we have to take out this kind of loading coil because of the frequency response feature for this kind of loading coil. Okay, we need to understand when we're doing the cable testing, what we need to test here is the major items we need to test. When we design the exchange area, I mean the area here means that the size of the area that share the same area code. Just like here, we use area code 315 here. Okay, the size have to be decided based upon different factors, such as subscriber density, distribution, traffic, etc. The trade-off between exchange size and the high cost of subscriber loop, we have to consider it when we decide the shape of the service area. The exchange location means that where we need to put those exchange or switches is based upon the serial card. The method we use here is called center of gravity. It means that we need to have the switches installed in the center that would have the maximum utilization of the link wire. Means we have to use the minimum length for the links to reach the maximum amount of customer. Okay. So if we put the switch in the center of the gravity for a certain region, we can achieve that. It's some kind of optimal approach to cut the cost. There are different ways we can connecting center office. One is to directly connect them, directly, or use a tandem switch. Means that we can use few trunks and also have alternative paths. They have certain kind of pros and cons for these kind of different approaches. Normally, we would have analog trunks in the less developed region, such as some kind of remote area. The voice frequency repeater, or we call it voice amplifier, is used to extend the link length. It have to be able to pass the DC signaling. The dimensioning of trunks, when we decide it, we have to take into consideration that would allow for future growth. I mean, you have to forecast the potential increase of the traffic in the near future when you design the trunk. I mean, it's very costly to put another cable to accommodate additional traffic. So in general, we have to put more than necessary for now, those kind of capacity underground for those kind of trunks. When we build trunks, we have to foresee the development in the near future. And we need to understand different kind of K value means different kind of traffic flow direction. Okay, we also need to aware what kind of features modern telephone network can provide for us, such as call waiting, call forwarding, three-way calling, etc. And also caller ID, call trace, so on and so forth. Okay, here in general, in chapter 2, we need to understand the basic element for the local telephone network and how we design the link length and how to extend the length and how we decide the size of exchange area and the shape and where to put the exchange switches would be the optimum location. Okay. Okay, let's move on to the next chapter.